Hello. Hi, good evening all.
Hello, good
Good
evening.
evening, ma'am.
Yeah, good evening. Uh, so did you all gone through the last session till RAL model? Any doubts? Pranay, how many sessions you have completed?
Yeah, I Prashanti. Uh, I have just started and it's some more time.
Okay,
Mm.
fine. What about Vishal?
Uh, I have to go through the last session. I have gone through all the session before that.
Okay. Did you understood all the sessions?
Yeah,
Configuration,
most.
DB and factory registration.
Yeah,
Okay. What about remaining Vinita, Sheetal, Selva Kumar, Sandeep, CB?
Yeah, Prasanti, I have gone through, but last session I need to listen it again. But I have a doubts in the UVM specific interview questions you have posted, right?
Yeah,
That
last
I have a
set a question. I need to check that. I will check and I will let you know.
sure.
Yeah. Other than that, any doubts?
No, but RAL I need to practice. I haven't practiced the RAL thing, the RAL model. Apart from that, everything is fine.
Okay. RAL model, we discussed two sessions only. As of now, we are
Mm.
discussing only two sessions. But in RAL model, we need to discuss some more sessions, some extra 2 to 3 sessions. In the March, anyway, we need to extend this course, right, till advanced level. Like advanced level in the sense which we need to discuss more briefly till projects in UVM projects. So in the March, we are going to extend this, but till by March first week, we need to complete as per our syllabus, workshop syllabus. We need to complete this. So till now, we have completed introduction to UVM, UVM agent, UVM phases, TLM ports, UVM configuration, factory registration, and UVM reporting mechanism. We need to discuss. RAL model is for 2 days. So we have discussed for 2 days RAL model part 1 and part 2. So I think everyone got clarity about the RAL model, front door access and back door access. Even for front door access, we have written the code also. What are the steps we need to follow? And leftover topic is a virtual sequence. Okay, so I need to complete reporting mechanism and virtual sequence. It takes 2 days. After this basic topics, after this I mean all the topics, next shift register, RTL design, and adder RTL design, FIFO memory, and final 2 days AXI protocol, VIP development, AXI protocol, part 1, part 2, 2 days. Okay, so other than this, for regular batch, we need to discuss more into the RAL model and also virtual sequence concept, deep into the virtual sequence, and also we need to discuss the two UVM projects. Mostly one router project we are going to discuss in UVM, and also orbiter project we will discuss in the UVM. Mostly almost by end of March, we are going to complete the UVM. Okay, so till then we will discuss. So today I want to discuss on adder example. Okay, so next session we will discuss the register example, and coming session, third session, we will discuss FIFO memory. After FIFO memory, we will discuss the virtual sequence concept and also reporting mechanism concept. Okay, so 2 days, 7 days left. Okay, so today we will discuss on adder example. Any doubts still here, everyone?
Mhm.
Did every concept clear? If you have any doubts, we can have some doubt discussions from Sheetal, Sandeep, Shalva Kumar, and Parth.
Hello.
Yeah.
Actually, in the RISC model, you mentioned the comparison, right?
Comparison, which one?
We compare the transaction, right? I mean, mirror value, updated values.
In RAL model.
Yeah. In that, in which component we are comparing in the same scoreboard, we call the mirror and the update values, and we compare in the scoreboard or in the any other component.
Not in the scoreboard. We need to write in the predictor logic.
Okay.
In predictor logic, we need to compare mirror value and expected value.
Actually, in the scoreboard you mentioned, right? Normally, we will compare the golden value with the reference
value, DUT value, and expected value. We will compare in the scoreboard. That is not related to RAL data, right? RAL data we will compare in the predictor. We will write separate predictor block. In that we will compare the RAL data.
Okay. So
even in your scoreboard also you can write the predictor logic and you can connect.
Actually, in the scoreboard, whatever normally we use the normal sequence to generate the random value. Same we do the RISC model. So scoreboard, there is no
same process, but syntax will be different. Here we call as a monitor to RAL from through the adapter. It converts into the register sequences. From bus sequence, that register sequence will have the mirror value and expected value. That will be done in the predictor. So we need to write within the predictor block. You can also write in the scoreboard.
Okay. Yeah, that is my term.
Okay. Others? We will discuss RAL model also using SPI. We will discuss in the last session. I will give you some overview. Actually, it is not in the part of this thing. We didn't add it, but I will explain you. Okay. I think no doubts from anyone. So we will start working on UVM codes. So you will get the clarity. So daily for every alternate day, we are going to discuss. So total 3 to 4 designs we are working on. So if you at least work on these 3 designs properly, you will able to write your UVM test bench, your own UVM test bench. Okay. So everyone try to practice. I will explain you clearly. First, we will start with the adder example. Okay. So here is the adder design, right side one. Name of the module is adder, input, clock, and AB also. Input clock resetter, AB inputs, and sum is the output. So how we can write the output in the always block? Always at the rate of POS clock. If reset is high, sum is equal to 0. Else sum is equal to A plus B. Okay. So that is how we can put. If you are writing for full adder, you can put the carry also. Okay. So full adder or even ripple carry adder. After this example, you can try with another example from your side. Okay. So first of all, whenever we are writing some program in SystemVerilog or UVM, we need to follow the flow. Then it is easy to write any type of test bench. Okay. So in the flow, first of all, what we need to write? First, we need to write an interface. Why? Because through the interface only, we are going to connect DUT and the test bench, right? So that's why start with the interface. Interface is very simple block. It's a common block, and also internal logic also common for all the examples, right? So start with the interface here. So how we can write the interface? However, we put in the SystemVerilog same. Here we don't write any class. Interface is not a class. Okay, you just we use a keyword. Interface is just a keyword to we use to connect the design and the test bench. Okay, so interface, name of the interface, add if, and we need to pass these control signals, clock and reset. Okay, and logic A, B, sum. A, B or the input, sum is the output. And clocking block, you already know what is the use of clocking block and a mode port, right? For more synchronization purpose, we use the clocking block and the mode port. So this is our DUT, and for the DUT there will be a interface, and to the interface here we will connect a test bench. This is our test bench. So to this interface we will connect a test bench and the DUT. Okay, so here we are writing the interface. In test bench we will have the two blocks. One is a driver, one is a monitor. Okay, so from the driver we will pass the data to DUT, and from the DUT we will get the data to the monitor. Okay, so these two things, these two are asynchronous. Okay, so asynchronous in the sense both will work with a common clock. Okay, for more synchronization purpose between communication between driver to DUT and DUT to monitor, we use the separate clocking blocks. Okay, one clocking block is for driver to interface, another clocking block is for interface to monitor. Okay, so two clocking blocks we need to write. And also mode port. Mode port is used to define the port list from driver to interface and interface to monitor. Okay, so that's why clocking block, name of the clocking block, driver clocking block is a driver CB at the rate of POSIX clock. And also this skew, we need to mention the skew, just extra delay. So according to that skew delay, we can sample the data, input and outputs. So another thing is you already know in driver, outputs will be declared as a input must be declared as a output. Why? Because suppose what are the inputs to this driver? A, B are the inputs which are getting from the sequencer via mailbox or TLM port. Okay, but these inputs are going to the DUT. These inputs are going to DUT means what? These inputs will work as a output to the driver. Okay, and inputs will work as a actual outputs will work as a input to the driver. It's a bidirectional. Okay, mostly we won't get the data from DUT to driver, but driver is a bidirectional, both input and output we can give. Okay, so from driver to DUT we can send the data, from DUT to driver the output will be sent to the driver. Okay, but if you see the monitor never send the data to DUT. Okay, whether it's a input or output, whatever the variables, monitor never send the out some data to DUT. Always it get the data from DUT only. Okay, so that's why whether it is a input or output, anything we will get the data to the monitor. Okay, so that's why all input and outputs will be declared as a inputs in the monitor. Okay, in the driver, inputs will be declared as outputs. Outputs are declared to the input to the driver. Okay, so that's why if you observe here, AB are the inputs actually, but AB are declared as a outputs. Okay, and next input sum. Sum is also output to the output, actual output, but to the driver it's a input. Okay, And clocking block monitor CB. For monitor, it's reverse. All inputs will work as a all data will be coming to the monitor. Okay, so that's why all these are inputs. Okay. Next, mod port. Mod port is also same. We no need to write separately. Whatever the clocking block is there, we can directly include here. Why? Because in clocking block already we kept all different variables. What are the outputs? What are the inputs? Like that. So that's why you can directly insert clocking block here. Okay. And mod port monitor clocking block CB. That is how we can put. Okay, for driver mode port and for monitor mode port, separate port list for more synchronization purpose. Okay, and here included assertions. In this code we have written coverage and assertions also. Okay, we will discuss that coverage and assertion part also. Clear everyone till here? Any doubts? Any doubts here?
No. Prashanti, one question. So, using the hash delays, is it advisable in general? Or
Wait,
this
here,
is just an
because
input
this
hash
is
one?
skew. Yeah, we need to put hash delays because those are the skew. Skew means what? We need to define the sampling rate. So at what sample time the output will be, like at what rate the sampling is done, like that.
Okay.
That's why we put just minimum delay. Suppose in Verilog HDL we put time scale, time precision, right? Like that here we put this clock skew.
Okay.
Okay. Next. So first we have written the interface. This part is clear. Okay. So after writing the interface, next we need to write the transaction class. What is a transaction class? Transaction is nothing but, suppose here we have a sequencer. Okay, in a UVM there will be a sequencer. Sequencer will be sending the data to the DUT. Okay, so that is what the transaction data. How it is sending to the DUT? Via mailbox. In SystemVerilog we use a mailbox, but in UVM we use a TLM port, right? So we need to write the TLM port. First, we write the transaction class. Why? Because main transaction is the data. Main data will be there in the transaction class. That too, whatever the constraints we are taking, everything we write in, we put in the transaction class. Okay. So in SystemVerilog we call it as a transaction, but in UVM we call it as a sequence item. Right, sequence item in the sense all the variables or attributes, or we can also call as fields. Okay, so we need to write the transaction class after interface, nothing but sequence item dot sv. Okay, so how to write the sequence item? Sequence item is an object. You already know sequence item, sequence or object in UVM. Remaining all are components, right? So class sequence item extends UVM sequence item. UVM sequence item is the parent class. Everything, every functionality in the UVM will be there in the parent class libraries only. That's why every class we need to extend from UVM parent class only. Okay, whether it's a sequencer or driver or monitor, everything we need to extend from the UVM parent class. Okay, so here sequence item extend from UVM sequence item. Next, as it is an object, you already know how to write the factory registration concept. For object, we write the UVM object utils. For component, we write the component utils. Okay. And another thing, we need to define the fields here. Why? Because here in sequence item, we have the number of variables. The number of variables also need to be registered. Why? Because to access the do hook methods, or we have copy, compare, clone, print, all these methods. So to access all those methods, we must need to register the variables or objects or classes. Okay, so that's why we write the UVM field int a comma UVM all on, all off. Before I already told you, these are the not only verbosity levels, we are just controlling. So UVM all on means all methods we can access. Okay, so if you don't want to access any method, like if you don't want to access copy method or compare method, then you need to write UVM all on plus no compare, no copy, like that. Okay. Reporting mechanism we have not completed. We will discuss that thing more clearly. So next, object utils end, begin end. For all components, we don't write a begin end because it's a single statement. But if there are multiple statements, we need to put the begin end. Okay. Next, input A, B, sum. You already know what is the need of rand, right? And also function new constructor. For every class, we need to create the class or object. So that's how we allocate the memory. So by using the function new constructor, we are allocating the memory to the class here. Okay. Next, constraints. Here addition means a simple constraint. But if you go some complex circuits, like before we have worked on 4-port calculator or some different projects, right? There we have written different type of constraints. But here A, inside it is generating 1, 2, B inside constraint. Okay. End class. So this is how we can write the transaction class. Everyone clear? Any doubts still here?
No,
So
ma'am.
after writing the transaction class, yeah. Okay. After writing the transaction class, now we write a sequence block here. What is meant by sequence? In a SystemVerilog, we have a generator block, right? Same here, we use a sequence block in place of generator. Okay. So, however, in generator, we do the randomization and we send the data to the DUT. Okay, by using the mailbox, we put into the mailbox in the driver, sorry, not DUT, driver. In the driver, by using the mailbox get method, we get the data. Okay. In the same way, here we have a sequence. You already know the transaction flow. In the first session itself, I have explained the transaction flow. So requesting for the data by using the get methods and put methods, or by using the TL import methods, driver will initiate the, here sequence will initiate the transfer, and driver will get the data. Okay. So same process we do. If all transactions are completed, item done will be giving from the driver to the sequence. Okay. So in the sequence, we do the randomization. Where is the sequence here? So see, class add sequence extends from UVM sequence. As you already know, sequence is a parameterized class. So that's why we need to pass the transaction. Sequence item is the transaction, right? So that's why we need to pass the sequence item here. Next, object utils. Object utils, because it's a sequence is a object, so that's why object utils we need to write. And UVM declare P sequencer. P sequencer also we didn't discuss. We need to discuss in the virtual sequence concept. Virtual sequence and virtual sequencer concept. We discuss the P sequencer and N sequencer. Okay, why I kept in the hold in the sense, just if we complete these type of examples, you will try to practice overall test bench architecture, right? That's why I just kept those two concepts on hold. Okay, so that's why. Next, class constructor. Next, virtual task body. In a sequence, we write everything, main functionality in the body only. Why? Because phases we never write in the objects. Okay, even if you say sequence item or sequence, there we never use the phases concept. We write in the driver, monitor, environment, okay, scoreboard, like that we write the phases. So in sequence, we need to write the body method. You already know the callback methods. We have pre-body, post-body. So pre-body, post-body are the callback methods where we add some extra functionality without changing the main functionality. So if you want to add some pre-statements or some post-statements, so we can use the pre-body and the post-body. Okay, but main body is the virtual task. Okay. Mostly in UVM, we will declare all methods, tasks, or virtual only because we can access everywhere. Okay, we can override the data. Next, repeat, begin, creating the request because by using the request only, we will send the initiate the transfer to the driver. So sequence item, request, and assertion. We are using the assertion. If you don't want to use assertion, we can use if request dot randomization is high, then transaction is successful. If randomization is not high, failure. Like that we can write. Okay, or else we can write the assert request dot randomize. And you already know, without writing these 4 steps, we can also replace with a UVM do macro. UVM do or UVM do with the macro. If you want to write the inline constraint, we can write UVM do with macro also. Okay. Next, a finish item of request. That is the flow from sequence to the driver. If you remember the transaction flow, then you can understand. If you didn't remember, just go through the PPT. There clearly mentioned the sequence flow from the driver to sequence to driver. Okay. So after finish request, at same time parallelly write the driver also. Okay. So now we have written this sequencer. Now write the driver after sequence. Sequence after driver. Okay. So what will be there in the driver? So here driver is connected to the DUT via virtual interface. You know already why do we use the virtual interface, right? So by using the physical interface, we need to create the virtual interface and we need to set the path to the DUT via virtual interface. Okay. So tick define. DRIVF is the name of that macro, define macro. VIF. VIF is the virtual interface. If you see 6th line, virtual, add if is the name of the normal interface, physical interface. VIF is the name of the virtual interface. Okay, so we need to write the VIF. So VIF dot, what is this driver? Driver, this name is nothing but mode port driver name. Okay, mode port driver name dot driver CP. So this is how we are accessing the variables A, B, C, sum. Whatever the variables are there, these variables only we are passing the data through these variables to the variables. So that's why this is how we can access the interface via virtual interface dot mode port dot driver CP. This is same from SystemVerilog also we did same. Okay, both are similar. Next, class driver extends UVM driver hash. Driver is also a parameterized class. So we need to pass the sequence item. Okay. Next, driver is a component. It's not an object. Before sequence item, sequence, all these are objects. So that's why we have written a UVM object util. But here we need to write the UVM component utils. Okay. It's a macro. And then creating the virtual interface and also creating the class constructor. Okay. Now in the components we write the build phases, build phase or connect phase or run phase, end of elaboration, start of simulation, extract phase. There are a lot of phases, right? Everything we write in. No need to use all the phases. So as per the requirement, already we have discussed phases concept very clearly, right? So as per the requirement, we can use the phases. Okay. So first build phase. What is meant by build phase? We need to just create the we just need to create. Okay. So function void build phase. UVM phase is the parent name. We need to pass the name, phase name here. Super dot build phase of phase and UVM config DB. We need to get the data from the UVM config DB. You already know how to write the set method and get method in the configuration DB. And also if it is a component, how to write. If it is an object, how to write. We already discussed clearly. Okay. So write the UVM config DB here. Next, end function build phase. Okay. Next, run phase. We don't write the connect phase in the driver. Why? Because this driver, monitor and sequencer, we are going to connect a top level of agent, because agent is the top level of these three components. So we need to make the connections of these three in the top level. So in the driver, we don't write the connect phase. Okay. Next, virtual interface, virtual task, run phase. Because run phase is a task, remaining all phases are the functions. You already know what is the difference between function and a task, while the run phase is a task and the remaining phases are function, right? Next, UVM phase. Forever begin. Here we are getting the data. Sequence item port dot get next item of request. So by using TLM port. Okay, one will be the target, one will be the initiator. So if we are target to initiator means what are the methods we need to use? Initiator to target means what are the methods we need to use? You already know based on the put port and the put method, get port and get next item, it will be reverse. Okay. So sequence item port dot get next item of request, and a drive method we are calling here, and sequence item port dot item done. So here we are passing the item done, and that item done will be get to the sequence. So here finish item. Once item done is completed, we are writing the finish item. Okay, in a sequence. That's how we write the run phase. These 3 points here, and in sequence these 4 points, main transaction flow. Okay. Next, after that, main drive method, we need to pass the data to the DUT, transaction to the interface, virtual interface. Okay. So how we are accessing the transaction data? Transaction data will be there in the request.a, and the DUT data will be there in the virtual interface. Through the virtual interface, we will connect. So why we are writing here driv.a? Because driv.if is the name of this path. If you don't write this macro, instead of the drivf, I'm just copying this path, and you can put here instead of that vif driver.cb.a. So this a is sitting in the driver cb. So that's why we need to mention this path. Okay. If you don't want to mention every time this entire path, we can just simply put the macro. Okay. That's why we just write this macro here. And same here also, driv if dot b is equal to request dot b. And next, positive edge of the clock, we are getting the virtual DUT data to the transaction data. I already told you, right? In driver, it's a bidirectional. Data will be sent and getting. So that's why we written this. End task and class completed. Okay. Any doubts here, everyone?
Oh no.
Okay, so we have written the driver now. Okay, now what is the sequencer is here? You already got the idea of what is meant by sequence item. Sequence item means transaction class, and sequence means where we put the data and randomize the data, and the flow from transaction flow will be happen from sequence to driver. Okay, now here it's a sequencer. Sequencer is the mediator between sequence and the driver. It connects the sequence to driver. That's what we call as a sequencer. Okay. So what logic we need to write in the sequencer? By default, we don't need to write anything. Whatever we written till now, we didn't write any functionality of the block. We just written some additional things what we need to do. Okay. But we didn't written anything regarding the UVM Testbench architecture. But because all the things will be default, all the things will be there in the libraries by default. So we no need to bother about the functionality. In the same way, sequencer is just a mediator. So we never write anything about the mediator logic. By default, it will be there in the library. So go to the sequencer. any program, whatever you took, like any type of design or project, everywhere we just put these two lines. First, we create the class sequencer, extend a UVM sequencer. It's a parameterized class. We need to pass the parameter sequence item. And as it is a object, we need to create using the component utils. And it's a we need to create the class, right? So that's why we use the class constructor. That's it. Only simple logic we need to write. By default, mediator logic will be there in the UVM sequencer. Whenever we are calling this class sequencer is the child class of UVM sequencer. So the child class will access all the properties of the parent class, right? So that's why we no need to bother about the mediator logic here. Okay.
Hi, sequencer is an object or a component?
It's a component. We have only two objects in the test bench, sequence item and the sequencer. Remaining all are components only.
I didn't get, like, a sequencer is an object or component?
Sequencer is a component. That's
Okay,
what
then
I'm
it should
telling.
have to. Okay, I understand. Okay.
Only sequencer, sequence item, only these two are
Okay.
objects. That's why we write in using the object utils here. So if you see here, object utils, and sequence is also object utils. For sequencer, it's a component, so component utils. Okay, so now we got this entire flow. Okay, and we need to design the monitor now. Monitor is getting the data from the DUT via virtual interface. So we need to write the monitor block here. Okay, so this is what monitor driver. So go to the monitor block, monitor.sv, same driver we need to write, but simple modifications. So we are defining the path here. MONIF is the name of this macro, and VIF.monitorCB is the clocking block. VIF.monitorCB. You can also write VIF.modport.monitorCB also fine. Both we can choose. And next, class monitor, extend from the UVM monitor, creating the virtual interface and creating the component utils and analysis port. So why we are writing the analysis port, you already know. For sequence to the driver or sequencer to driver, we just write the TLM port. Why? Because it's a one-to-one connection. But analysis port means one-to-many connections. So here we are connecting many components. Like if you observe, we have two components. One is a coverage. We are taking the coverage also, and the scoreboard also one of the components. So two components we are connecting at a time. So that's why one is for coverage, one is for scoreboard. That's why we use the analysis port here. Okay, monitor to both the blocks. So UVM analysis port hash, it's a parameterized port. So sequence item we need to pass. Item collected port is the name of the analysis port. Okay, so sequence item, it's a name of the, trans collected. It's a transaction. Sequence item is the transaction class name, right? So that's why we need to create the instance. And class new constructor. You already know why we should take this. And next, build phase. So getting the data, config data. So we need to use the get and main run task or run phase. So in the run phase, we need to collect the data from DUT to transaction class. So what is the transaction? Here we have written as a trans collected, but in driver we just written as a request.a. Just we have written as a requester, but in monitor we have written as a trans collected. Okay. So driver side, right hand side is the driver data using virtual interface, and left hand side is the transaction data. So whatever the data is there, A, B, from a driver from DUT to, sorry, I told driver before, not driver, DUT. Okay, so DUT data passing to the left hand side transaction data. And next, At the rate of next positive edge of the clock, we are collecting the output, which is a sum. So DUT dot sum is equal to transaction collected. Okay. So here we are displaying the values by using the print method. We use the print method to print the output data. Okay. And if you see here, item collected port dot write of trans collected. Actually, in SystemVerilog, we use the mailbox concept. Even if you write from monitor to scoreboard, or if you connect a monitor to some other block, wherever, we use multiple mailboxes for each one. Okay, so same way here we use the write method because we are using the analysis port, right? However, we use in the driver get port, put port. In the same way, here we use the write method, so that directly we write the data into the TLM port. While we are accessing also, we do same. And the task, that's what monitor. Okay. Clear everyone till here?
Yes.
Okay. So now 3 components are completed. One is a scoreboard, driver, and monitor. Okay. So these 3 will be connected to the agent. Agent is the top level of these 3 components, and that too it's an active agent. You already know what is the difference between active agent and passive agent. In active agent, we have 3 components, 3 active components: sequencer, driver, and monitor. In passive agent, we don't drive the data to DUT, we just monitor the data. We just read the data from the DUT. So that's why we connect only monitor. Okay. So here these 3 components are available. So we will call it as a passive active agent. Okay, so these 3 things we need to connect in the agent top level. So next, write agent after that. Okay, and in agent we need to include all these sub blocks: sequence item, sequencer, sequencer, driver, monitor. These things we need to include in the agent. So class agent extends UVM agent. Sequencer, sequencer 1 created the instance for driver, driver 1 for monitor, monitor 1. So agent is a component, declared as a component utils. And constructor, we need to write the constructor. And the build phase, in build phase we need to create the driver, sequencer, and monitor. If it is a passive agent, we need to create only monitor. Okay, you already know how to create. No need to explain the syntax. We have written a lot of times till now. And then connect phase. In agent, we need to write the connect phase. Why? Because we are connecting driver to sequencer, monitor to scoreboard. But in agent, we don't connect the monitor to scoreboard. Why? Because in agent, we have the connection only sequencer to driver only, not from monitor to scoreboard or coverage. In environment, the top level, we connect the monitor to scoreboard or coverage, okay, by using analysis port. But in agent, we write only sequencer to the driver. Okay, so driver dot sequence item port dot connect of sequencer 1 dot sequence item export. You already know where we need to put port and export. Okay. So that is how we write the connect phase. Clear everyone?
Yes, ma'am.
Okay. So after that, now we write the scoreboard, monitor to scoreboard. Okay, scoreboard block separately, and then coverage block also we write separately. So go to scoreboard.sv class scoreboard extends from UVM scoreboard. It's a component, so that's why we declare it as a component utils. And UVM analysis port. So you already know why do we use the analysis port. And sequence item data And we need to create the queue because here we compare comparison logic we need to write. So when we write the comparison logic, we should allocate some memory for that. So that's why we create the queue. Even in SystemVerilog also we create some queue, right? Queue or memory, whatever we can create. So here created a queue and class constructor and build phase. In the build phase, we are just creating the item collected export. And in the write method, why we are using the write method? Because we are taking it analysis port. So for analysis port, we use the write method. So getting the data here and trans collected dot print method. Okay. So trans collected dot print method means whatever the data we have took from the monitor, collected from the monitor, we are printing that. Okay. Packet queue dot push back. So one by one data we are by using the push method. You already know the queue methods. We have push friend, push back. For retrieving the data, we use pop friend, pop back. Okay. So here we are sending the data to queue. That means we are storing the data into the queue. That's why we use the push method. Okay. Next in the run phase. In the run phase, we just pop the data and do the comparison. Okay. So virtual task run phase, sequence item sequence, and forever begin wait until packet dot size is greater than 0. Okay. When size is greater than 0, then only queue have the data, right? If size is at 0, queue doesn't have any data. That means empty. If it is empty, in the memory we don't have any data, so we can't do comparison, or we cannot, the functionality will not work. So queue size must be greater than 0, whether it's a 1 location or 2 locations or 3 locations, whatever, it have some data. Okay, we need to check that condition. Even for FIFO also we check empty full condition, right? So same way we write the queue condition here. And in the sequence we got stored some data into the sequence. If you see here, sorry, not into the sequence, push queue, packet queue. Into the packet queue we stored the data by using the push method. Now we are popping the data. That means we are retrieving the data, or we can call as a reading the data from queue. Whatever we read the data, that data we are storing into the sequence from the queue. Okay. Next, comparison logic. For addition, comparison logic is very simple. If a plus b is equal to sum, if both are equal, both a plus b value and sum value, then it's a true, or else it's a false. Okay. So if sequence A plus sequence B is equal to sequence dot sum, then write all the statements. Test pass, value of A, value of B, value of sum. Okay. Else, UVM info statement test failed. If both are not equal, we write as a test failed. Okay. Clear everyone till here? Clear everyone?
Yes, ma'am.
Yes.
Okay, fine. So till scoreboard we have completed. Now coverage report we will discuss in the end. Now this sequencer, not sequencer, this agent plus scoreboard. Agent plus scoreboard we need to write in the top level environment. Okay. So we need to connect from monitor to scoreboard in the top level environment. Okay. So next we need to write the environment.sv. See here. Include agent.sv, scoreboard coverage. Coverage also is there in environment only, but we will discuss coverage later. Okay. Suppose if you don't write the coverage in your example, you need to follow in this flow, like after scoreboard environment, you need to write. Okay. So include agent.sv, scoreboard.sv, coverage.sv, class environment extending from the UVM environment, agent, scoreboard, coverage instances, and environment is also a component. So component utils and class constructor and build phase In the build phase, we create the agent scoreboard coverage. In agent, we have created, right, a driver, monitor, and sequence. Same way we need to create here. And also we need to connect agent to monitor scoreboard and agent monitor to coverage. Okay, if you see here, these two are analysis port. How we connect the analysis port? There we don't have any get port and put port. Okay, just we connect like this: agent dot monitor dot item collected port dot connect to export. Okay, and also here analysis export. Clear everyone? Environment.
Yes.
Next, after environment, top level is tester. In tester, we'll have the sequence. This sequence and
Can you
environment
repeat environment again?
and interface. What?
Can you show the environment again, once again?
Okay.
Yeah, if you can explain this connection between monitor and scoreboard.
Here. Actually, here we are using the analysis port. Okay, so this item collected exporter, and in monitor we have written item collected port. So go to the monitor. See, analysis port, item collected port. So how we need to connect here? This agent, inside the agent only we have a monitor. So agent dot monitor dot item collected port dot connect off. To which one you are connecting? Scoreboard, suppose. In scoreboard, how we have written? See here, in scoreboard, UVM analysis implementation. These two, just a second, I have to put charging. Okay, if you see here, analysis implementation port. So in the scoreboard, we need to write this syntax, analysis implementation. In monitor, we need to write a UVM analysis port. Okay. So in scoreboard, how we have written sequence item dot scoreboard item collected export. Export is the name of that scoreboard. Okay. But how we will connect just a monitor dot connect of scoreboard. That is how we write. But this export, all these are names, just names. That's why you may confused. Okay. So go to the environment. If you see here, agent.monitor.item collected port dot connect. Connect is the main syntax. Connect of scoreboard dot item collected export. Okay, this monitor mailbox, monitor analysis port instance connecting with the scoreboard analysis instance. In the same way, monitor dot item collected port dot connect of coverage. In coverage, how we have written the names, if you see. Right method, function new constructor. Okay, for coverage directly we written as a analysis export. Analysis export is a syntax here. We just connecting the analysis export like this. Okay, did you understood now?
Yeah, thank you. Thanks.
Okay, so now environment is completed. Okay, next layer is test. In test, we have the sequence and also interface and also environment. 3 blocks will be there. Okay, so now write the test.sp. See here, include environment.sp. Okay, and class test extend UVM test, and component utils sequence will be there, and environment will be there. Oh, okay. So in the test we will have only sequence plus environment. Sequence plus environment. In the test bench top level, we have test and interface. Okay, so in test we have sequence and environment. So add sequence, environment, class constructor, and function virtual function void build phase. So in the build phase, we will create the sequence and also environment and the build phase. Now we are writing the run phase. You already know phase dot rise objection and phase dot drop objection, right? So we will discuss more clearly in the factory registration, not registration, reporting mechanism concept about the phase dot rise objection and phase dot drop objection. Okay. So what does it mean generally? Just to check the number of transactions are correct or not, equal or not at the receiver side and the transmitter side. Okay, so rise objection will be written at a receiver transmitter side, phase objection will be written at a receiver side. Okay, when both are equal, suppose we are initiating 10 number of transactions. Okay, so at the phase dot rise objection, it will check it's equal to 10 number of transactions. So other than if it not received 10 number of transactions in the driver, near driver, it should not it should not stop the transmission of all the transactions. It should wait until it get all 10 number of transactions. Okay, once it is driving all these transactions to the DUT, then we'll get the drop objection as high. So whenever phase dot rise objection and phase dot drop objection, when both are equal, the transactions are equal. Okay, just to check that condition, we write these things in the run phase. And sequence dot start to the sequencer. We need to pass the sequence data to the sequencer, right? From the sequencer to sequencer, one by one transaction. So by using the start method, that's a default method. We need to use only start method. Okay, so sequence dot start of sequencer. Sequencer where we have in the environment within the agent. So that's how we are connecting. Okay, clear everyone till here? And next, virtual function void end of elaboration. End of elaboration means what? Final changes we can put here. If any final changes are there, we will print here. And topology, printing in a topology, hierarchical way. Okay, this is how we write the test. Clear everyone?
Yes, ma'am.
Okay. After test, top level is test bench. From here, in test bench, this test will be included and this interface will be included till here. Interface will be included. Test plus the interface in the top level test bench. Okay. So go to the top level test bench. So here you need to include all macro, because in entire test bench we have used the UVM macros. So you need to include UVM macros.svh. In that only we have all the libraries. Okay, UVM libraries. And also you need to include the UVM package, import UVM package. Here also we will have all set of libraries and whatever we are deriving the classes, everything will be there in the UVM package. And then include the interface.test in top level test bench. Okay. Next module, test bench top bit clock reset. You already know from Verilog onwards we are writing the test bench, right? Same here also. We initiate the clock reset and we generate the clock cycle and also reset, and we need to connect the DUT interface here, and here we are setting the data configuration data by using the set method. Okay, so this is how we write the test bench top level. Everyone clear till here? Everyone clear? Did you understand how to write the test bench, whole UVM test bench, how to make the connections?
Can you explain this config DG, where to where it is connected, from top to test or from test to driver, like that?
First of all, here we are setting the config data. Just a simple set method we used. Actually, config data means what? We can control lot of things, whether you want to put active agent or passive agent, or scoreboard is enabled, scoreboard is disabled, or coverage enabled, disabled, or if there are multiple number of agents, because when you connect in SOC level, we'll have the multiple number of IPs, right? If there are multiple number of IPs, for each one we write the UVC, universal verification component. For every universal verification component, there will be an agent. Okay, so for every agent, like there are 10 number of agents. So these are different number of IPs, IP1, IP2, IP3, IP4. So for this one agent, second agent, third agent, fourth agent, sometimes you will enable this agent 1, agent 2, or agent 3, agent 4, or disable. Like that, we will have lot of configuration. Okay, so these things also we can mention in the config DB. Everything we can customize. But here we didn't mention all those things. This example is purely concentrated on basic UVM environment and also coverage assertion. Okay, in the next classes or in the next session, I can explain you the how we can put the configuration database also by activating the agent, these scoreboard, these things. Okay, so here in simple configuration DB, we just kept the set method. Just we just kept some data using set method, and it is getting from UVM root. You already know UVM root is a top level of environment where we have all basic libraries from UVM root. All are extended from the UVM root. It's a parent. Okay, so this one we need to get in the driver and also monitor. See, in the build phase configuration data, and also in the monitor build phase we have the configuration data. Like that, mostly we put in these two only. Scoreboard also we can put sometimes, or is not required because we already written these connections. In build phase monitor, sorry, in driver monitor we don't write any connections, right? In every block agent also we have the connections. Connections in the sense we need to create these things. We need to create the components. Okay, so that's why mostly in the driver and the monitor we write the configuration DB. If you see here, get in test bench top level we put as a set method. Here we use the get method, and that too here it's a component. That's why we use this. If it is an object, we use a null. Like that, it will be different.
So in the top we will set, and in the driver and monitor we will do the get method.
Yes.
So in some of the test benches I have seen that in agent they have used first they
Set
will use in the top they will set, and after that in agent they will get. Again they will do set method in agent also, and again they will do the get in monitor and this driver.
Yeah, we can do. We can write separate files also. You can write create the separate class for configuration DB, and that one you can get to the driver. We can use the set and get method anywhere. But based on if there are more number of controllability, as I told before, we can control everything agent and like a scoreboard. All these things, if you want to control, you can write anywhere wherever we get proper space and wherever we can enable properly. Suppose if you are writing related to agent, you can put in the agent itself.
And which is a recommended way?
There is nothing like that. It's no we can't say what is the recommended
Like
style.
general
We can
used.
in the top level we write. Suppose a driver is the low level, right? So in the top level agent you can write, or environment you can write, or in test bench you can write like that.
Okay.
Okay. Any other doubts? Now we write the coverage. Coverage and assertions are extra. Like if you want to use, you can put, or else no. Okay. So how we can write the coverage? First of all, what is the use of coverage? What is the use of coverage?
To track the report of the how many bins are read.
Okay.
To check all the functionality of our design is covered or not, ma'am. Whether all the functionalities are verified or not.
Okay. So in the coverage, mostly like whatever the verified scenarios are connected properly or not, whether we are testing all the scenarios properly or not, we can check through the coverage. Okay. So if coverage report is not 100%, there is something left to verify. We didn't cover all the scenarios, like that we need to understand. Okay. So my how to write the coverage. My coverage extends UVM subscriber, just a name, and also passing the sequence item and component utils, creating the transaction class and cover group. We need to write the coverage report in the cover groups. If you want very detailed explanation about the coverage, I will share you the recorded session already available in the YouTube. Okay, in semi-design page. So just go through the coverage session. You will get more clarity. What is the use of coverage? Why do we write the coverage? And in that we will find lot of errors. So how we can find those errors and how we can debug the coverage reports, these things. Okay. So option dot comment, just this is to print the statement. Option dot per instance equal to 1. That means not to it just print the blocks like coverage report, it will print. And for cover point, this transaction dot a, we are taking multiple cover points. In multiple cover points, we write the number of bins. Okay, so this low a means it is covering between 0 to 9. High a, it is covering between 10 to 15. So within 2 bins we are checking the coverage. Like that you can write multiple number of bits or bins. Even 4 number of bins you can write. 4 number of bins means how we can divide 16 by 4. So each bin will check with the 4 bits. Like that 8 number of bins also you can write. Okay, if you write a more number of bins, there is a possibility of hitting more number of times. Okay, or else anything is same. If you want to hit more number of times each bit, then you can write the multiple number of bins. Okay, but we cannot write a very less number of bins, and we cannot write a more number of bins. Every time we need to write a moderate. Okay, so that we can check every scenario properly. Next, cover point B. For this also we took low and high and end group and creating the class constructor and also write method. My coverage dot sample. This is the syntax default method. Okay, so how we can sample the coverage report in the sense by using the sample method. My coverage dot sample. Function void report face, UVM face, and UVM info get full name, just a info statement to print the coverage. Okay, so clear everyone how to write the coverage. Like this, there are a lot of methods to write the coverage. I think you already learned in SystemVerilog. Any doubts still here? No? Okay. Next, assertion. How to write the assertion? Assertion is nothing but basically we use to validate the behavior of a design, right? So at every positive edge of the clock, whether the output is correct or wrong, it will check by using the assertion, just design validation. So we write two type of assertions: immediate assertions and concurrent assertions. So here we have written a property, addition, logic, output A, output B. At the rate of POS clock, if reset is 0, assigning A is equal to OPA, B value to OPP, and here triggering. This is how we write the trigger. Sum must be equal to output A plus output B. End property, assert property. So every positive edge of the clock, it will check whether this condition is correct or wrong. Okay, coverage we write for verification purpose as a verification engineer. Assertions are written to the design. For designs, we write the assertions. Mostly design engineers also write the assertions. Okay, mostly to validate the behavior of the design, we write the assertion. Okay, and to verify the functionality, whether all test scenarios are covered or not. For that purpose, we write the coverage. Both are different. Okay. Clear everyone till here? And final block is a run.do file. Run.do file is for coverage based on what tool you are using. For every tool, we have the different commands, right, for coverage. So here for EDA Playground, we use these commands. If you use QuestaSim or Model Simulator, or even in EDA Playground, if you use Cadence or Synopsys, whatever, these commands will be different. So you no need to concentrate about the commands. Why? Because it totally depends on the industry. Every company have their own commands. Okay, they will design according to their prototypes. Okay, so no need to worry about the commands. Other than that, everyone clear? Any doubts? So do simulation. Compilation successful, 0 errors. So here getting the coverage and coverage report also downloaded. So we'll get the output here. So if you see here, hierarchy, we are writing in the topology, right? Somewhere we have written topology. So it is printing like that. Top level UVM desktop environment. In environment, there will be agent. In agent, there will be a driver. In driver, there will be two methods. In agent, there will be a monitor also, and sequencer. And after agent in environment, there will be agent coverage scoreboard. Okay, so this is how we check top level. And values in transaction collector in monitor. So how the values are collected here. Value of sequence item in scoreboard. So check here. Test pass. Value of A equal to 0. Value of B equal to 0. Value of sum equal to 0. And then next, again test pass, value of A equal to 2, B equal to 5, sum equal to 7. Next sequence, another one, check everything. I will share you the codes. Okay, go through that. And coming to the coverage report. So if you see here, report summary, report counts, total info statements 105, no UVM warnings, UVM error, UVM pattern, and test done, top level and scoreboard, finish, $finish at 521 line, and report information here. These all are not required, and coverage information. And here is the coverage report, cover group. Total number of hits 66.66%. And goal is 100%, but we reached only 66.6%. So where we didn't reach properly, we need to check. Cover point also 50%. Okay. Low 20 number of hits, and for A, high A, 0 number of hits. Okay. So based on the output, you need to check where we didn't took the possible combination. A high means what? Between 15 to 8, right? 0 to 7 or 15 to 8. So within a 15 to 8, we didn't took any value. Okay. So based on that, we will check 100% coverage for low B, high B. Okay. So total 50% coverage report we got, but 100% coverage we need to reach. So how we can improve the coverage? Can anyone tell how we can improve the coverage? CB, can you tell how to improve the coverage?
We can increase our test scenarios, ma'am.
Okay. We need to increase the test scenarios. Other than that,
Give some
maybe. Yeah, sorry, go ahead.
in constraint. We give some less inputs only, ma'am. So if we want to cover everything, so in constraint we need to give some more inputs. Instead of
for
restricting,
A, we return the constraint, right? For A.
Yeah, we have written constraint for A.
Sequence item. Okay. For A, we have written all our 1 to 5 only. We didn't written for higher values. Okay, so if you see here, low A, 20 bins, okay, hitting. But for high A, it is not hitting, 0. That means for A only, we written the constraint, that two lower side values only we have written. For B, we didn't written any constraint, so it is generating all scenarios. Okay, even high side, low side, 0 to 15, every value it is generating. Okay, so I will show you. Suppose here I'm in after 5, I'm writing a 8, and also I'm writing 10. Okay, now we'll check what will be the output, whether we get the coverage report or not. It should do randomization between those values, right? We'll check whether we get 100% or not. Even single bit hitted also will get 100%. So like that we need to check. So I think you got understood now what is meant by coverage. So it will give you the report where we didn't cover the proper scenarios. So now we got understood, like only lower side we covered all scenarios, at least 3 scenarios we covered. Higher side we didn't cover any scenario. Based on that we are modifying, because that is one functionality we are not verifying, right? That is one type of test case we didn't include it. So that is how we are including. So now check the coverage report. See, 100%, 100%. Low A 16, high A 4. So those are number of hits. Even 1 we got also, that's okay, fine. At least 1 hit is okay. Okay. So 100% or 100% clear. Expected 100%, we got 100%, but before we got 66.66%. Okay, that is how every time coverage should get 100% only. Even 99.9% also not accepted in the industry. We must get 100% coverage. Based on that, we need to write our test scenarios. If any test is a failing, coverage will also fail. Coverage will be reduced. Okay. So this is how we can check the coverage report. Everyone clear? Understood? Any doubts?
I have doubt, ma'am. We can also remove some bins, no, ma'am. If you are giving some constraints, we can add some default bin, or we can remove some bins which consider that higher value as a hit count. So by taking that also, we can get 100% coverage.
See, removing bins means what? You are removing some functionality. It seems you cannot remove the bins. Bins we need to check every scenario we need to put here. We cannot remove the bins. We need to put all the scenarios in coverage. If you see some example cross coverage, have you? I think you attended for cross coverage, right? So how many number of scenarios will be there in the cross coverage? There are a lot of scenarios, right? So those things also we need to put here. Not only these bins, cross bins also we need to put. Okay. We cannot remove the bins. According to the bins, what test cases are not hitted, what test scenario we are not covering, like that we need to put. Suppose before a simple example, here we didn't included that value in the sequence item. We just kept only lower side values, higher side values we didn't kept. That means we are not verifying that test, right? So if we don't verify that test, we don't get the proper value. We cannot tell our functionality is correct. So that is reporting by coverage. Okay. So that's why we need to put all corner case scenarios. We are we need to understand which scenarios we need to put. Then we will hit the coverage 100%.
Yes, ma'am. Understood.
Okay. Any other doubts? I will share the code. I think already included these codes in the sheet. So everyone go through that and just revise the session once again. Okay. Any doubts from Vinita, Sheetal, Akash, Vishal, Salva, Gulshant? Any doubts? Karti?
Nothing from my side.
Okay. Ashas? Okay, then that's it. Thank you all.
Thank you, ma'am.